Good day once again. My name is Graphics. Today we want to analyze this circuit under it is a series and parallel network. Why do you call it series and parallel network? It's because of what? It comprises of both parallel and series connection, right? So now if this is our voltage source, if it produces a current, the current flows. That one current that is flowing, when it gets to this junction here, right, it splits. So we assume that the current coming through here is I1, the current coming through here is I2, and the one coming through here is what? I3. So because three different currents are flowing into three different resistors, we say that what? Those three resistors are in parallel. And how are we going to do that? Let me assume that this resistor here is R1, this one is what? R2, and this one is what? R3. So you write that for our RA, right, is equals to what? R1 parallel to what? R2 parallel to what? R3, right? Three of them are in parallel. So there's a formula for this that says that my RA will now give us what? R1, R2, R3 all over R1, R2 plus R1, R3 plus R2, R3. This is the formula for it, instead of taking them one after the other for three resistors, right? Now my RA here now will now be, this will now give me, what is my R1? My R1 is 10, my R2 is 5, my R3 is 15, all over my R1 is 10 times what? R2 is 5. That's the first one. R1 is 10, this plus R1 is 10 times R3 is 15 plus R2 is 5 and R3 is what? 15. So this is what we're having. Now if you multiply it together, 10 times 5 times 15 will be, that will give us 750 all over, that is 10 times 5, 50, 50 times 15 is what? 750. Now all over 10 times 5 is 50 plus 10 times 15 is 150 plus 5 times 15 is 75. So from here, this will now give me 750 all over 50 plus 150 is 200. 200 plus 75 is 275. So we're having 275. So 750 divided by 275 will be 2.727. So we're having 2.727 ohms. That's the unit for what? Resistance. Now I will now withdraw. Now withdrawing, we're having this. So we've made the entire circuit here. This 1, 2, 3 in parallel we solve for it is now a single one, which is giving us our RA, and that is what? 2.727. So RA here is equals to what? 2.727, and this is 6 ohms here, 6 ohms. This is another ohms here, then this is 8 ohms. So I have redrawn this and I'm having this, right? So this is what we are having. I've redrawn them. So the only thing I changed was this man here, making a single one with this and this. Now we proceed in proceeding, if you notice it, the same current this 50 volts produce, which is our I total here, they call it, let me say, the IA, coming here, the I total, passing through this. When it gets here now, it splits, right? And what? It splits. So this resistor here and this resistor here are sharing one current source coming, right? So let me call here to be my R4 equals to this, and I'll call it to be my R5 equals to this. So R4 and R5 is what? In parallel. So I'm going to put it this way. I'm going to say that my R4, that is my RB, is equals to what? R4 parallel to what? R5. So this will now give me R4, R5 all over what? R4 plus R5. And this will be, what is my R4? That is 6 times what? 8 all over 6 plus what? 8. And this will give me 6 times 8 is, that is 48, right? All over 6 plus 8, that is 14. So 48 divided by 14 will be 3.429 ohms. That will be my what? My RB. Now, when you withdraw, we end up having this, because we've made this 2 equals to 1, and that is my what? My RB. So my RB is equals to what? That will be 3.429. We have 3.429 ohms, right? And my RA still remains where it is because it's in series, and that will be what? 2.727 ohms, right? So from here, if the current still produces come here, it is a series, so these two are now in series, so that will not be our R equivalent. So you now write that the R equivalent, since there is no longer any resistor aside from these two, is equals to what? RA plus RB, in brackets you're going to put in series, right? So from here, what is my RA? My RA is 2.727 plus my RB is 3.429. So this will now give us 6.156 ohms, and that is our what? R equivalent, right? So we've gotten this. Now we want to calculate the current that is flowing through. So calculating for current. Now we know that our V is equals to what? IR. That is what? Our Ohm's law, right? So if we make I to the formula, my I will be equals to what? V all over R, right? And that will be, what is V? V is 50, and R is what? 6.156, and this will give us 50 divided by 6.156. That will be, so the current flowing through will be what? 8.122 amperes. That is the current flowing through the circuit, and that is our what? Our I total. So the I total is this particular part here. This is our I total here, right? So the current that this 50 volts is producing, that is coming down here, is giving us what? Our I total, and that is 8.122 amperes. So when this 8.122 amperes, that is 8.122, when it flows in here, it splits, right? So these three are in parallel, So we need to look for the current, that is I1, I2 and I3. And calculating for the current here, this is what we are going to do. We'll be using current divider rule to calculate the current I1, I2 and I3, because we say in a parallel connection different current flows through. So let's see. Now using current divider rule, from this our parallel formula here, we want to calculate for I1. So calculating for I1, right? So we'll come to this man here. We need I1, so we're going to remove arrow A and place I1 here. So we'll say I1 equals to, now you ask yourself a question, where is I1 flowing through? I1 is flowing through arrow 1, right, which is the 10 ohms resistor. So I'm going to remove arrow 1 from this equation here. So I'll be having arrow 2, arrow 3, all over what? Arrow 1, arrow 2, plus arrow 1, arrow 3, plus arrow 2, arrow 3. Now I remove the arrow 1 because of I1 is flowing through. So because I remove the arrow 1 now, what would I do? I will now replace it with what? I total. Because I removed it. So I replace it with what? I total. So this will now give me my I total is what? 8.122. 8.122 multiplied by arrow 2. Arrow 2 is giving us what? 5 ohms. Multiplied by arrow 3. Arrow 3 giving us what? 15. All over. Everything I have here is the same thing. So I'll just simply put my what? 275, because they are all the same. So 275. So I'll have my 275 here. So this will now give me 8.122 times 5 times 15. So that will be 609.15 all over what? 275. So this will now give me, divided by 275, will be 2.215. 2.215 amperes. So the current flowing through the arrow A here, arrow 1 here, is 2.215. Now the next one is for I2. You follow the same procedure, right? Remove the arrow A here, you put your I2. Now since you put your I2, you ask yourself, where is I2 flowing through? I2 is flowing through the arrow 2, which is your 5 ohm resistor here, right? So you're going to remove the arrow 2 and place the rest. So if you remove the arrow 2 from arrow 1, arrow 2, arrow 3, it remain arrow 1 and arrow 3 here. So I'm going to place my arrow 1, arrow 3, everything remain the same. Arrow 1, arrow 2, plus arrow 1, arrow 3, plus arrow 2, arrow 3. So because I've removed the arrow 2 here from here, I'll now place my what? My I total. So in this case here now, my I total is what? 8.122 multiplied by my R1. My R1 is what? Is 10. So multiply by 10. And my R3 is what? 15. Multiplied by what? 15. All over. Everything here remains the same. Nothing changes. So everything is what? 275. So I'm having my 275. Are we good? So in this case here, I'm going to be having this 8.122 times 10 times 15 will give 1,218.3 all over what? 275, right? So divided by 275, and that will give me 4.43. So my current here is equal to what? 4.43 amperes flowing through the arrow 2 ohms. Now the next one will be I3. Calculating for I3, the same thing happens here too. In I3, where is I3 flowing through? This I3 here coming is flowing through arrow 3, which is 15 ohms. That means in this here you are going to remove the arrow 3 because the I3 is flowing through it. So you are going to replace it with what? Your I total. So what I'm writing is this. I'm writing it this way by saying my I3 is equals to, I'll just write R1 R2 all over R1 R2 plus R1 R3 plus R2 R3. Now because I remove my R3 because I3 is flowing through it, I'm going to place what? My I total here. So what is my I total? We know it is 8.122 multiplied by R1 is 10 multiplied by R2 is 5. Yes, R2 is 5. Now nothing changed in the denominator here, so that is what? 275. So when I do that, I'll be having this. So we're having here to be 406 all over what? 275, and that will give us what? That will give us 1.477 amperes. So that is the current that we're having. Is my I1 is giving us 2.215. My I2 is giving us what? 4.43. My I3 is giving us what? 1.477. If you add all this, you should be having our I total back. So let's try that and see. So when you add them, you recall that everything here will give us what? Will give us 8.22. If you sum of these things, you'll be having 8.122 amperes. Right, so that's telling us that what? The current that is entering this node that is spread across this resistor, the same current here that will be coming here will be what? I total here, and that is what? 8.122. right? Here is 8.122. Here also is what? 8.122. Now the same thing will happen here. These two now, let's assume that I5 is flowing through here, and here let's assume that what? I6 is flowing through here. So you do the same process and you see what will happen here. So what will you do? You go to the other one that deals with what? I5 and I6, which is this. If you look at this now, we said earlier that what? These two is in parallel. So we now assume that the current flowing through here is what? I5, and the one coming here is what? I6. So what you simply have to do here is just you calculating for I5. Calculating for I5, you go to where RB is. This RB, right? You are going to remove RB, that is the current divider rule. You put I5, right? Now you ask yourself, where is I5 flowing through? I5 flowing through R4, which is the 6 ohm resistor, right? So you are going to remove R4 and put your I total. So it will be, you just write only R5 all over what? All over R4 plus R5. All over R4 plus what? R5. But because I remove R4, because I5 is flowing through R4, so you put your what? Your I total. So we know that our I total is what? 8.122 multiplied by my R5 is what? R5 is 8 all over what? 6 plus 8, because R4 is 6, R5 is 8. At the end of the day, we're going to be having this. We're having 64.98 all over what? 14, because 6 plus 8 is 14. So we divide it, we'll be having 4.641. So we have 4.641 amperes. So the current flowing through this I5 here is what? 4.641 amperes. Now the next thing will happen to the same, you repeat the same process. So calculating for I6, and then for I6, you go back to this guy. You're going to remove the RB here. You put I6, that's the current divider rule. You place your what? Your I6 equals to, now the question you ask yourself, where is I6 flowing through? I6 is flowing through what? R5, which is the 8 ohm resistor. You are going to remove R5, and that will be left with what? R4. So I'll be having R4 all over R4 plus R5. Because I've removed R5 now, I'm going to put what? I total close to it. So the I total is only replacing the R5 only on the numerator, not on the denominator also. So from here, this will now be, my I total is 8.122, right? And multiplied by my R4. R4 is given as 76 all over. Everything remains the same. R5 is saying 6 plus what? 8, and that is 14. And we'll be having 8.122 times 6 divided by 14. So that is 3.481 amperes. So that is my I6, right? So we've gotten the whole current in this resistor. So if this video if you find this video helpful, please don't forget to click on subscribe button and don't forget to share with family and friends. Thank you very much.